So class, this will be the last video for section 12.1. So now let's look at some distance between 2 points in space. So for example, if we want to find the vector from A, which is 1, 3, 4, and B, which is 4, 2, 7. So let's first write as position vectors. So we could say that OA, we could say that's I plus 3J plus 4K. And we could say OB is going to be 4I plus 2J plus 7K. So written as position vectors in unit vector form. Well, again, I know my distance between, so AB is OB minus OA. So again, I have just two arbitrary points A and B out here in space. If I wanted to find this, I'm going to reference some origin. All right, so I could go OA and then OB is my vectors. But because I want to go the opposite, so I want to go from A to O to B, it becomes a negative OA. So I can go in column form. So OB I know is 4, 2, 7. Subtract 1, 3, 4. This becomes 3, negative 1, 3. So my vector AB, given the position vectors from the start, is going to be 3, negative 1, 3. If I wanted to find the distance between these 2 points, so again, distance is magnitude. So I'm trying to find the magnitude of AB. So I'm going to look at it as 3 squared plus a negative 1 squared plus 3 squared again. And so this becomes square root of 9 plus 1 plus 9, which is just the square root of 19. So the magnitude, the distance between these 2 points, is the square root of 19. Unit vectors. So let's talk more about unit vectors. So unit vector form is that I, J, and K. Now we're going to be even more specific and say a unit vector is a vector of length 1. So this is important. It is length 1. So we're going to define our vector in terms of a unit vector that is guaranteed to be length 1 in a given direction. So to do this, a vector of length 1 in the direction of A. So again, this is that boldface A to represent a vector. So this is the same thing as saying like OA as a position vector. So a vector of length 1 in the direction of A is found by multiplying the vector A by 1 over the magnitude. All right. Boldface A written out, you sometimes might see it as a lowercase a with a line under it. So it's hard to write a boldface A. It's easy to type a boldface A, but it's hard to write a boldface A. So you might see it written, or you can write it as A with a bar under it. And that, again, will represent what our vector is. If we wanted to find a vector now of any length, so we can make a unit vector, which we know is length 1. Now, if I want it to be length 15, if I find my unit vector of length 1, I would just multiply that by 15 to get a vector of length 15. So to find a vector of any length, we're going to say k by first finding the unit vector and then multiplying by that k. So this is that k, like that scalar multiple. We're going to multiply by some value of k. So we're going to take our unit vector a, multiply it by 1 over the magnitude of A. So that gets us a length 1. So all of this gets us a unit vector of length 1. But if I want it to be now, say 15, I'm going to take 15 and multiply it by that vector that I know was length 1. So this is going to be k times my vector a all over the magnitude of my vector. So this will make sense. We'll do an example here in a second. But this formula, this first we want to figure it to a unit vector of length 1 and then multiply it to get it to a new length, whatever length that we set it to be. So if we want to find a unit vector in the same direction as the vector 3i plus 4j. So 3i plus 4j, again, we could write it in column form. We could say 3, 4. First off, we need to know the magnitude. And the magnitude is going to come from square root of 3 squared plus 4 squared, which is square root of 25, which ends up just being 5. So now we want to multiply our vector, so 3, 4, times 1 over our new magnitude, which is 1/5. Now, to multiply by a scalar, we are going to multiply 3 times 1/5 and then 4 times 1/5. So this becomes 3/5 and 4/5. So this is our unit vector in the same direction as 3i plus 4j. This has a magnitude of 5. This has a magnitude of 1. We could also write it in unit vector form in terms of the i's and j's. So this would be 3i plus 4j is our unit vector form times 1/5 to end up being 3/5 I plus 4/5 j. So that's the same thing. It's still magnitude of 1. All right, so now let's find a vector of length 10 in the same direction as 3, -1. So first off, we got to figure out the magnitude of this one. And so that's going to be 3 squared plus -1 squared, which is square root of 10. So we're going to take our vector 3, -1 times now 1 over that magnitude, root 10. But remember, we want this all to be a length of 10. So I'm going to multiply all of this by 10 because this only gets us length 1. Multiplying by 10 guarantees a length of 10. So this is really 3 -1 times 10 over root 10. And again, I'm going to multiply each piece separately. So if I were to multiply each piece separately, well, actually in this one, let's rationalize the denominator of this one. So 10 root 10, if I were to multiply that by root 10, that root 10, it ends up being 10 root 10 all over 10. So those go away, so it's just root 10. So all of this over here, I have 3 -1 times root 10. So that k value is my root 10. And if I were to work this out, I could say 3 root 10 all over -1 root 10 in column form, or I could say 3 root 10 I minus root 10 j in unit vector form. But that is a vector in the same direction as 3 -1 that is a length of 10. Okay, so here's a couple of practice problems for you to work on. This is the end of 12.1. 12.1 had a lot of foundational pieces to it that now we can build upon. So if you have questions on this one, email me. We'll work through them, work through the practice problems. I'll provide the solutions as well, and we'll keep moving forward.